So our goal for today, okay, is that we're going to review the stuff that you need to know how to do on the calculator. So we'll work some questions together. Y'all will have at least 30 minutes, hopefully closer to 45, to work on your practice test that we just kind of have been working on for the last week. So for this first one, will you type this into the calculator, please? Okay, for the entire AP Calc test, you should be in radian mode. You should never switch to degree mode. If you reset your memory on the calculator for my class, that's probably a good idea. Because pre-cal keeps switching in. Okay. Then go ahead and type this in. Okay, instead of a T, you're going to use an X, but we know it's the same thing. Okay, the other thing you need to know how to do for the graphing questions, okay, is you need to know how to adjust your window. Okay, so when you hit the window button here, it says that I'm only looking at 0 to 6. So that's going to be your X min and your X max in the window button. Okay. And so you should know how to adjust that, but in case you don't, I'll show you right here. Okay, we're going only from 0 to 6. Okay, then once you have that, go ahead and sketch the graph on your paper. Okay, so it goes something like that. All right, this is a graph of V of t, which we know means velocity. So the first thing you are asked to do is to find when the particle changes direction. What would I be looking for on this graph if I want to know when the particle changes direction? When it goes through the x-axis. Very good. So the first, if you look at your little list up here, these are the things you need to know how to do. Okay, you should be able to graph. You should be able to find intersections. X-intercepts are also an intersection. You're just going to let your y2 be a 0. Okay, then second trace 5. And then first curve, second curve, and then get close to it for the guess. Okay. So I can see that my graph crosses the x-axis at t equals 3.910. Okay. Then it says, for when does the particle change direction? Let's also pretend that it asks you to justify. Just because on the AP test, it'll say stuff like explain your reasoning, justify, whatever. So you would put because V of t changes sign. Now, if you're trying to specify that it's like a max, you would have to say the direction. Okay, but changes sign is good enough for changing directions. Okay, the next question that you're asked to find is the acceleration at 4. If this is velocity, what do I need to do for the acceleration? Take the derivative. Very good. So if I have acceleration, I need to take the derivative, which is math what in the calculator? 8. Very good. So I'm going to exit out of my graphing screen. And I'm going to do math 8 d dx alpha trace y1. I want the derivative at 4. Now, for the AP test, you don't want to just leave numbers out there. So if you're wanting to show that you're taking the derivative, you would just put the acceleration at 4 is v prime. Okay, you're not going to actually take this derivative by hand, but you want to write on your paper what you did in the calculator. So if I took a derivative, v prime is going to tell whoever's grading your AP test what you did in the calculator. Okay, and then the answer comes out to negative 3.637. 3.637. Okay, remember, you can always go longer on the decimal, but shorter than 3 decimals, they're going to count it wrong. So like 3.6 would not work. Okay, next question asks me about speed. What do I have to look at for speed? It's 2 things. Velocity and acceleration. I already have acceleration right here. How did it come out? What type of number? Negative. Then I need to know, is my velocity also negative? So in your calculator, velocity at 4 would be the y value. And you have 2 places you can get the y value. If it's a whole number, you can just look at the chart, but you should also know on your home screen that you can just do that to get your y value. So regular y1, tell it to plug in a 4 for you. And I got negative 0.329. Okay, negative 0.329. So if my acceleration was negative, I already found that. Now I see my velocity is also negative, then what would my conclusion be about speed? Good, increasing. So I'm going to put speed is increasing. Because, and then don't put like they're both negative. You need to say what they are. So you'd put A of 4 and B of 4 both negative. What's up? Huh? A coach asked where you were for a scout. It was Mervicker, both negative. But anyways, I told her that you were getting breakfast because you'd already left. Yeah, that's it. Okay. All right, next 2 are both averages. Now, keep in mind that you were given velocity. So you have 2 averages. You have average rate of change, or AROC, and you have average value. So if this is velocity, which one would average acceleration be? Would it be average rate of change or average value? Average rate of change, very good. Because remember, from velocity to acceleration, that's a rate of change. Versus from velocity to still velocity, this is average y value. Okay, and then you should know the formulas for those. The first one is f of b minus f of a over b minus a. This one is 1 over b minus a integral a to b. So b of 4 minus b of 0 over 4 minus 0. And then we'll do this in the calculator, but just make sure anything you're doing on the calc test with the calculator, you write it down first, then punch it in. Okay, then this one is 1 over 4 minus 0, 0 to 4. Okay. Then go ahead and type both those in. See if you have any issues with any of that. Okay, you can see me type it in if you need help. Dumb question, but you do have his permission to get here, yes. Okay. Gotcha. Gotcha. Yeah. Good luck on your test. Okay, so there's the first one. It's y2 minus y1 over x2 minus x1. Okay, that's your normal slope formula. And then your second one is your average. Anybody need help on typing those in? Okay. Next question asks about traveling towards or away from the origin. What 2 things do you need to know about for towards and away from the origin? Position and velocity, very good. Now, for my velocity, what feature is that? So if I have velocity typed in, this would just be the y value, right? So find b of 2 in your calculator. That would just be your y value, which is 7.322. But the other thing I need to know is position. And remember that if they gave you velocity, they had to tell you the position somewhere in the question. Okay, you can't use velocity to go backwards without them giving you a starting position. So look back at your question. What did they tell me the position is at 2? Okay, right here it says the position of the particle is -2 at 6. That means that my position is right there. Now, using those two pieces, it can tell me which side I'm on and which direction I'm headed. So if my velocity is 7, am I traveling left or right? A positive velocity means I'm traveling to the right. But a negative position tells me I'm starting on which side of the origin. I'm starting on the left. So you can draw yourself a little diagram here. If this is the origin, I'm on the left, but I'm traveling to the right, then am I going towards or away? That would be towards. Go towards the origin. Okay, one more question like that. They gave me the position at 2, but they're asking me for the position at 4. So this is going to be where you want the position at one number, but you have it somewhere else. So write down the position that we want is 4. The position that we have is 2. What do we need to add to the position at 2 to know the position at 4? The integral between those times. Very good. Okay. And you know it's an integral because you were given velocity, but you're trying to work backwards to position. So remember, velocity to acceleration is a derivative. Velocity to position is an anti. Okay, then from there, you would just do this in the calculator. What is the position at 2 that was given to you? So you would type in -6 plus. And then for this integral, you would just math 9 it from 2 to 4. And it would give you your answer. Okay, just like that. Alpha trace. Alpha trace to reuse your y1. Okay. So I got 1.085 for that. Okay, remember you can also you can always go longer than 3 decimals, but don't cut it shorter than that. Okay, last question on this page asks you for distance traveled. What do I need to change in my integral to turn it into distance instead of displacement? Absolute value, very good. So you're going to integrate from 0 to 6. And then for distance, because it's always positive, you're going to put absolute value bars around your integral. Okay, and sometimes these are kind of hard to find, so I'll remind you where those are. So type in your math 9 for your antiderivative. We're going 0 to 6. There are 2 places that you can find the absolute value bars. One of them is alpha window, but everyone forgets that. Hit the math button and then go over to number, and ABS is right there at the top. Okay, so math button, go over to number, and then ABS is absolute value. Okay, then put your y1 inside that. Okay, and anytime that you're using an absolute value, your calculator is going to take a minute. So it'd be absolute value of your y1 dx. So 32.869. Okay, then one thing, just y'all know your test is on Monday for this. they have put a particle motion on the test in the free response every year for like the last 10 years. So if there's one topic that you want to get a lot of bang for your buck, this is a good one to make sure that you kind of have your crop together. They'll almost for sure be one of these. There's been one every year for like the last million years, at least 10 years, but I think it's longer. All right, turn the page. All right, for the next one, go ahead and type that equation into your y equals. Okay, this time I want you to adjust your window to only include 2 to 4. Okay, 2 to 4. So when I hit my window button, I want my X min as a 2, my X max to be a 4. Okay, then hit graph. Okay, your graph does something like that. Okay, keep in mind, this is a graph of f prime of x. I want to know where f has relative extrema. Relative extrema is talking about mins and maxes. Where would I find mins and maxes for f if I'm looking at f prime? Where it crosses the x-axis. How many times, it doesn't ask us to actually find them, but how many times does that happen? 1, 2, 3. Okay, so 4 times. Now, you could even isolate that to how many of them are mins and maxes, okay, based on how it passes through. Hopefully you know how to do that. Okay, next question asks me for point of inflection. Okay, so if this is f prime, point of inflection is talking about f double prime. What feature is that on this graph? It's the concavity on f, but it's the slope here. So I'm going to put here that point of inflection is f double prime of x, which is the slope on this f prime graph. And then I want to count how many times that slope changes sign. So put an X on your graph everywhere that your slope switches direction, and then count how many. Yes. So it's uphill till here, downhill till here, uphill till here. And then at the very end, it kind of cuts off before it really switches, so that doesn't count. So you would have 3 times for your point of inflection. Okay, but remember, you're not looking at changes in concavity on this graph because this is an F. This is F prime that we're using to answer questions about a graph we don't have. Okay, next one, I want regular F at 4. How do I go from an F prime back to a regular F? Huh? Not derivative. Antiderivative or integral. Very good. And remember, if you're going backwards, they have to give you a regular F to start with. So if I want capital F of 4 or regular F at 4, what regular F did they already give me? Okay, remember, they have to put it in the question for you to go backwards. So they told me F of 2 is 5. Then I can just integrate between those to connect the dots. So this is the F that I want. This is the F that I have. And then I connect the dots with an integral. Okay, then you would do this in your calculator. So go ahead and type it in. What is F of 2, it said? 5. And I would just do it all in one. So it'd be 5 plus math 9. We're going from 2 to 4. And then our y1 dx. So that would be 5.081 when rounded correct. Questions on that? All right, the next question is kind of the same, so we're gonna skip it. So go to the next page. Okay, look in your chart. C of T is degrees Celsius. Okay, and then it tells us in the question that our C of T is the temperature of coffee in a cup after it was taken, I guess, out of whatever the tea kettle. C of T is measured in degrees Celsius. Then it says you have values in the table. Okay, part A, I want C prime. How can I find C prime if I have C? Very good. Now on this question, it even tells you that. Okay, but a lot of times if they just ask you to approximate it, you would have to know that. Okay, but average rate of change is going to be my best estimate for slope. Okay, we're doing it on 3 to 7 because why? Because that's where 5 would best fit between. So for C prime of 5, we're going to use A rock on 3 to 7. Okay. Then from there, we would do C of 7 minus C of 5. No, wait, wrong. 3. And then over 7 minus. Okay, then remember from there, you just pull these numbers out of the table. So C of 7 we see is a 69. C of 3 is an 85. And then you could even leave this just like that. If it's not multiple choice, that's actually good enough. Okay, now it says show the work that leads to your answer. So you can't just leave an answer with no work supporting it, but then it asks you to include units of measure. So if this is Celsius, degrees Celsius, and I took the derivative, what should that turn into? Degrees Celsius per minute. Very good. What if I took the derivative again? Degrees Celsius per minute squared. Yeah. So this would be, I'm just going to leave it like I said, and then degrees Celsius per minute. Okay, but if they tell you to include units, usually that means they're giving you a point just for labeling that correctly. Okay, next question asks us for a Riemann sum using the left side. Can I do the short version or do I have to do the long for this table? Long, because my delta x's aren't always the same. So for 0 to 3, how wide is it? 3, and what's my left side y value? 100. So it'd be 0 to 12, C of t, approximated by, and then I would say my width is 3, my left y value is 100. Okay, next one, I'm going from 3 to 7. How wide is it? 4 this time. My left side y value is an 85. Last one is from 7 to 12. How wide is it? 5 units, and my left side y value is 69. Now notice the 55 never got used, but you always skip the last one on a left side anyways. Okay. Then if you wanted to actually add that up, you could, but since it's a free response, you don't have to. Okay, then it says, so let's put a little check here. We used the left Riemann sum to approximate this. Now it says to interpret the meaning of that with a 1 over 12 in front of it. Okay, that is the formula for what? Average value, very good. Average rate of change is this one. Average value technically would be 1 over 12 minus 0, but obviously they're not going to put the minus 0. So let's put 1 over 12 minus 0, 0 to 12. Okay, that's C of t represents. Okay, and now I want you to think about average value is short for average y value. So what do the y values in this table measure? The degrees Celsius of the what? Coffee. Then this would measure the average temperature of the coffee over that same time. Remember, average value is just average Y value. So if this is talking about how hot the cup is, this is the average of how hot the cup was. So let's put, this would represent the average temperature of the coffee in degrees Celsius over 0 to 12 minutes. So average Y value is just the average of what your Y value already is. Okay. Part C. Okay, so remember, the chart tells me C. Now they're giving me a C prime. Okay, and the C prime is the rate of change of basically how fast the coffee's temperature is changing. Okay, then it says, find the temperature of the coffee at time 2. So if I have C prime, and I want to go back to the temperature of the coffee, am I doing a Y value, a derivative, or an antiderivative? Anti, because this is C prime, and I want to go back to regular C, which is how hot the coffee is. So I'm going to put, I want the coffee at 20. And then where can I start with the coffee's temperature from? They had to give me some different temperatures, and I have several that I can choose from up here. Which time would I want to use the coffee temp at? So I'm going to use it at 12 because that's where the table starts, but you'll notice that's where my equation picks up. So I'm going to put C of 12 and then integral between them. So I know the temperature of the coffee at 12, that's the end of my table, but then that's where my equation picks up that I can use it to bridge the gap from 12 to 20. And remember, you would not do this by hand, you would do it in your calculator. So what is the coffee's temperature at 12? Pull it out of your table. 55 plus. And then rather than having you type that in, I'm just going to put calculator. Okay, but I'm assuming at this point you know how to do that. So you would find that number and then add it to the 55. Do you feel like you could do that? All right. Last part of this question, they give you a C double prime. Okay, of course, it's going to be a total pain to type into the calculator. Okay, but then it says determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. First question, when you take your coffee, okay, out of what you brewed it in, what's happening to the temperature? It's getting colder. We already know the temperature is decreasing. The question is it decreasing at a decreasing rate or an increasing rate? That's a concavity question. So all that you need to do, go ahead and do this for me now, is put this one in the calculator and then see between 12 and 20 if those numbers are positive or negative. So I'm going to go into my Y equals and type that in. And then when I hit graph, what part of the graph do I really only care about? 12 to 20. Now, if you want to adjust your window, you can, but the graph is so small that it basically looks like it's just on the x-axis. So instead of me using the graph, I'm just going to look at the table. So hit second graph and then scroll down to 12 and look at what types of numbers you see between 12 and 20. Okay, because when I hit graph, it's so close to the x-axis that I really can't even see it. But if I look at my table, What types of numbers do I see at 12? They're all what? They're all positive. They're tiny, but they're all positive. So that tells me that my C double prime of T is greater than 0 for 12 to 20. And that tells me that my graph is concave up. So that tells me the temperature is decreasing at an increasing rate. Okay, where this is the overall slope, but this is the concavity type. That my slope is negative because I know my coffee cup is cooling down, but concavity tells me how it's doing. Okay. Questions on that? All right, the last question we're going to do is turn the page. It's a nice area and volume, which was our last thing that we learned. So very, very last question for today. You have a lovely little area graph. Go ahead and type those equations into the calculator. Okay, type it in as your Y1 and your Y2. Yeah.
Thanks. First thing,
Uh-huh.
are we doing another packet like this?
We were gonna do some questions. But like 45 minutes. Kind of like we're doing today.
Of like someone like this, or I can help this?
It's I think all free response, but I just picked mixed topics. So it's not like just calculator or just one guy. Okay, for part A, they're asking you for area. So what's the first thing that you're going to need to find once you have those equations typed in? Okay, this is our last unit. What are you going to need to find? The endpoints, very good. Now this endpoint, if you read it, okay, it says the graphs shown intersect at -2. So they automatically give you this one is a -2, but you're going to have to find this one. Okay, so go ahead and do that now if you haven't already. Okay, so you want to find second trace 5 for intersect. Okay, and then I have a little bit of a problem. What's wrong with my graph? That I'm not even seeing it. My window, I never fixed it, right? I'm still looking at 2 to 4, I think. So I'm going to adjust it to match. I want a -2 to a 1. Okay, so if you haven't done that already, you won't even be able to see the equations if you don't fix that. Okay, then we're looking for that intersection. And then for the guess, make sure you get closer to the one that you're trying to find. So it looks like it's 0.782. Okay. Yeah. Yeah. Okay, from there, set up your area. Hit window. Go -2 to 1. Because see how on your x-axis, what's the smallest x? And then your y is. Now the graph should be fun. Okay, how do I find area? Do you remember what to do with the boundaries? You are going to integrate, but which order do you subtract the functions? Not right minus left. What will it be for this one? Top minus bottom.
That whether or not.
Yes, and most of the time, it's if these are x's, then it's top minus bottom. The right minus left is the one that probably won't be on the AP test, but could. Okay, so -2 to 0.782. And then remember, when you subtract for area, it needs to be top minus bottom. So my top function here is the ln of x plus 3. My bottom function is the x4 plus 2x3. But remember, you have to subtract them in that order. Now, because they gave me function names, I'm just going to reuse them. Okay, so this is f of x, this is g of x. That way you don't have to worry about putting the parentheses around this, because if you didn't put it, they would count it wrong. So if they call it f and g, you should call it f and g too. Okay, then type that into your calculator. So math 9, -2 to 0.782, y1 minus y2. Okay, just like that. Okay, your area should come out to 3.604. Okay. All right. Okay, we're gonna do 2 more parts. Part B on this is just kind of a random that I want to like stick to the most important stuff that will be on there. So skip to C. Okay, you should know how to find volume for cross sections, and then in part D for when it's revolving. So let's do C and D, then we're done. Okay, for part C, what shape are my cross sections gonna be? Okay, it says they're squares. How do I find the area of a square? Well, if it's a square, normally it's base times height, but because we know they're going to match, we can make it a b squared. And then remember that your cross sections are going to be top minus bottom through that area. So, for example, because it says perpendicular to the x-axis, if you remember, the x-axis runs this way, then perpendicular to that is this way. So that's how I know that my base runs top minus bottom instead of side to side. Okay, so perpendicular to the x-axis means that my base is top minus bottom, which is f minus g. And then remember, to turn that area into a volume, you just integrate it. So it'd be volume equals my base squared. And then remember that my base is the subtraction of those borders. So it'd be f minus g. Okay, you cannot reuse the parentheses the calculator gives you. Remember, you have to type this parentheses in yourself. Okay, so go ahead and put that in. Endpoints are still -2 to 0.782. Question, why don't I have a pi in the front of this one? Because it's not a circular shape, it's not rotating. So remember, squares, triangles, none of those are going to have pi's in them. So from -2 to 0.782, then I have to make my own parentheses with y1 minus y2 to square it. Okay, but you're grouping them together in the subtraction and then squaring. So we got 5.340. Okay, last part of this for part D, we want to revolve the region or rotate the region around y equals -3. Sketch that into your graph. Y equals -3. Am I going to have a gap or no gap? Okay, y equals -3 would be down here. And so then hopefully you can see that, yes, you are going to have a gap. And remember, if there's a gap, that means you're going to have 2 r's. Okay, so this is what I'm rotating around. Then my big R goes from here to the farther away function, little r's here to the closer function. So your big R should start here and go to the farther away function. That's big R. And then little r goes from here to the closer function. That's little r. But notice they're both top minus bottom because of how the region is set up. For my capital R, what is the top of it touching? What function? ln, and what's the bottom of it touching? -3. So then for my big R, it'd be ln x plus 3 minus -3. That's my capital R. And then for my little r, it would be the x4 plus 2x3 minus -3. Okay, then go ahead and set up your volume equation in part D. Will this one have a pi? Yes, because you're revolving. So it'll be volume equals pi in the front, -2 to 0.782. And then big R is f of x plus 3 minus little r is g of x plus 3. Okay, remember they should both be grouped on their own with a squared. You cannot reuse the parentheses that they give you when you open the integral. Okay. And then from there you should get your answer. Okay, also you cannot put the pi on the inside for this unless you're going to put it twice, because it needs to be pi r squared and pi r squared. So that's why for one of these, I would just put it on the outside so you don't have to put it twice. Okay, then go ahead and type that in and we're done. Okay, also make sure don't use 3.14. That's too short of a decimal. It's going to count it wrong. You need to use the pi button. So it should look like that. Okay, we got 67.858. Questions on that? Okay, I know everybody's not here today, but because I'm assuming some of you might be gone on Thursday, okay, there are a couple of things I have to tell you about your AP test. When does it start? 8 a.m. If you show up at 8:30, you won't get to test. So they're recommending you get here at 7:30, but 8 is when you're going into the testing room. Okay, you have to have Blue Book downloaded onto what you're testing on. So if you're using the school Chromebook, it should already have it. That's what you take ACT and SAT and all that stuff on anyways. But if you're bringing your own computer, Blue Book has to be downloaded or they're going to make you late test. Also, if you can't log into your College Board account, they're going to make you test late. And that's the week y'all don't have to come to school. So don't do that. Make sure right now, make sure Blue Book's on your little log out screen and make sure you know how to get into College Board. Okay, then the last thing that they're wanting us to remind you of is that when you're testing, if you go to the bathroom, don't close your Chromebook. Because if you do that, you're going to get logged out and you have to two-factor authenticate to get back in, which means you'd have to use your phone, which will just eat into your time. So if you do take like a bathroom break or whatever, just leave you can like 45-degree it, but don't fully close it. Okay? All right, you have 42 minutes. So let's work on that practice test that you have been working on. You can do it. Yes.
So is all of it on?
That's a great question. We'll go over that next time, but the multiple choice is all on the computer. The free response, you'll have a booklet that you're working your math out on, but the questions will be on the computer. But your actual like handwritten answers are what they were.
Let's see.
Yes.